In 1999, a 17-year-old boy named Ben Underwood lost both of his eyes to retinal cancer. The doctors told his mother he'd need years of training with a cane, maybe a guide dog, that his world had fundamentally changed forever. But 3 years later, Ben was riding a bicycle through his neighborhood, playing basketball with friends, and navigating crowded hallways at school without any assistance whatsoever. He wasn't using a cane, he wasn't using a dog. He was clicking his tongue and listening to the echoes. The medical community called it impossible. His doctors called it a fluke. But a small group of neuroscientists at the University of Western Ontario knew exactly what Ben was doing because they'd been secretly studying it for years. And what they'd discovered would eventually force them to admit they'd been conducting experiments that ethics committees would have never approved. Human echolocation isn't supposed to exist. For decades, biology textbooks taught us that certain abilities belonged exclusively to specific animals. Bats navigate using sonar. Dolphins map their environment with sound. Humans? We're visual creatures. We've evolved to depend almost entirely on our eyes. Except that's not entirely true, and researchers have known this since the 1940s. The first documented case appeared in a dusty medical journal from 1944. A blind man named Jacques Luciron described navigating Paris during the Nazi occupation by making small sounds and sensing the space around him. Scientists dismissed it as anecdotal, unreliable, probably exaggerated, but the reports kept coming. Blind children in different countries, with no contact with each other, developing the same clicking technique independently. This wasn't learned behavior passed down through communities. This was something humans could just do. That's when Dr. Melvin Goodale decided to prove it. The problem was, studying echolocation meant finding blind subjects and putting them in experimental situations that pushed ethical boundaries. They needed to map brain activity while people navigated obstacle courses in complete darkness. They needed to test reaction times in scenarios that could result in injury. They needed to measure echolocation accuracy in ways that institutional review boards would absolutely reject as too dangerous. So they didn't ask for permission. Between 2001 and 2006, Goodale's team quietly recruited blind volunteers, telling them it was a standard sensory study. What they didn't disclose was the full scope of the experiments. Subjects were placed in rooms with hidden obstacles, moving hazards, and sudden drop-offs while researchers measured their clicking patterns and brain responses. Some participants later reported feeling deceived about the risks involved. But the data they collected was extraordinary. Brain scans revealed that when echolocating, blind subjects showed massive activation in their visual cortex, the part of the brain that processes sight. Their brains were literally seeing through sound, converting acoustic information into spatial maps identical to visual processing. The tongue clicks produced frequencies between 2 and 15 kilohertz, bouncing off surfaces and returning with enough detail to distinguish texture, size, distance, even material composition. One subject could tell the difference between a tree and a telephone pole from 30 feet away. Another could detect a disc the size of a dinner plate at nearly 20 feet. The resolution wasn't as precise as vision, but it was functional sight created from nothing but sound and computation. Humans had possessed this ability for millennia, but because most of us never needed it, the neural pathways remained dormant. The research eventually went public in 2011 when the team could no longer hide the scope of their findings. The papers they published revolutionized our understanding of brain plasticity and sensory substitution. But they also revealed the methodological shortcuts they'd taken. Several ethics committees launched investigations. The university issued quiet reprimands. Some participants filed complaints, though most acknowledged the research had genuinely helped them understand their own abilities. Today, echolocation training is taught to blind children in specialized programs across the world. The technique Ben Underwood pioneered is now an established mobility method. Organizations like World Access for the Blind teach thousands of students annually. What was once dismissed as superhuman is now recognized as simply human, a latent capability waiting in our neural architecture. But here's what should disturb you. Those researchers broke rules because they believed the ends justified the means. They were right about the science, and their work has genuinely helped people. So what else are scientists studying right now in ways ethics committees would never approve? What other capabilities might be hiding in our biology, waiting for someone willing to cross lines to prove they exist? Ben Underwood died in 2009 at age 16 when his cancer returned. But the ability he demonstrated, the one science said was impossible, is now taught as standard curriculum. Sometimes the most important discoveries happen because someone ignored the people saying it couldn't be done. And sometimes that's exactly what should worry us.